TIM, or TIM, stands for Thermal Interface Material, or simply the stuff you put between your CPU and the cooler to fill the microscopic gaps and improve the overall thermal transfer. You're probably picturing a thermal paste right now, but TIM is a broader term that includes several kinds that you can use. There are mainly three types of thermal interface materials: thermal pad, thermal paste, and liquid metal. Each one has different properties and advantages for different scenarios. Thermal pads usually have the lowest thermal conductivity of all three types, but they're also the easiest to apply. They come in different sizes and thicknesses, which gives a great flexibility for different scenarios. For best results, it's important to pick the correct thickness for the gap. One of the biggest advantages of thermal pads is that they don't dry out or suffer from the pump out effect like most thermal pastes, so their performance stays stable over time. Some pads are even reusable, making them a cheap long-term solution. Thermal pads are commonly used in situations where consistent cooling is needed without regular maintenance or replacement. That's why you'll often find them on SSD heatsinks, VRM transistors, and other heat-generating components. Nowadays, there's a wide range of materials used for thermal pads, with most made from silicon or graphite. Higher-end pads use graphene, which offers excellent conductivity, but it's very fragile material, and it needs to be handled carefully as damage can reduce its performance. Graphene is also electrically conductive, so it must be cut to the exact size to avoid shorting nearby components. Another increasingly popular option is phase change material pads. These melt slightly when heated and solidify again as they cool, improving thermal contact and filling microscopic gaps better than regular pads. PCM-based pads are ideal for laptop CPUs and GPUs since they deliver performance close to thermal paste but without the need for replacement over time. Thermal paste, also commonly called thermal grease, comes in great variety of types and formulas. Some are thicker to reduce the pump-out effect, while others are more fluid for easier spreading and better filling of microscopic gaps. In general, thermal paste provides better conductivity than a standard thermal pad, but its performance declines over time as most pastes dry out. With the constant expansion and contraction of the heatsink, thinner, more fluid pastes can be pumped away from the contact surface, leaving tiny air gaps that reduce conductivity and raise temperatures. It's good practice to replace thermal paste anywhere from 6 months to 2 years depending on the paste type to maintain optimal cooling performance. Most consumer pastes are silicone-based with other additives and are not electrically conductive, so spilling a small amount over other components usually won't cause damage. However, spilling paste directly over the CPU socket could prevent the CPU from working. Some metal particle-based pastes are electrically conductive, so these should be applied with care to avoid shorting components. Liquid metal is exactly what the name suggests, an alloy of low melting point metals that's liquid or nearly liquid at room temperature. Commercial liquid metal products commonly use metals like gallium, indium, and tin in varying percentages. It gives the best thermal conductivity of the three, but because it's metal, it's electrically conductive and it must be applied very carefully to avoid shorting components. If it's spilled anywhere, it should be cleaned before powering up the system. Gallium, the active metal in many liquid metal blends, reacts with aluminum. It can penetrate the aluminum's oxide layer and alloy with the metal, causing embrittlement and surface damage. In short, you cannot use liquid metal on aluminum cold plates or heatsinks. With copper you can get a mild reaction and surface staining, but generally performance is not affected and the cooler won't be damaged as with aluminum. Best practice is to use liquid metal when the cooler and the CPU heat spreader are nickel plated, since nickel does not react with the metals used. If you're a beginner in PC building, it's safer to avoid liquid metal until you get more experience. That was a quick preview of the different thermal interface materials. If you learned something new, please give the video a like and subscribe if you want to see my future videos. Thanks for watching.